So the first part I'm talking about is the challenge and a lot of problems. Just the difficulty in making software as a service right is very difficult. So just again, it's a joint work and with Microsoft Research and a bunch of my students. Just as I mentioned, just today, increasingly people want to use, just web application, the program provided by cloud, and to replace your desktop application, right? And this is understandable. Why? Because just if you want to use some software, just desktop software, you have to purchase that, you have to buy it, right? Have to install the software. A few years later, just the thing's obsolete. You have to update it, right? And along the way, just people are going to send you a bunch of update, just patching, just a message. And if you don't patch it, it will be explored. And just if you patch it, you may have to reboot your computer. A lot of inconvenience, right? So people come up with this idea: why do we need to use? Why do we need to even buy, desktop software? We can rent it from cloud. Right. So the idea is, just we have all the software in the cloud. Whenever you want to use it, you just visit their web repository using your browser. Click the button, you can use it. Once you have it done, you give it back. Right. You just pay, just pay for the time so you use that software. Right. Is that a good idea? In this case, you forget about. You don't need to worry about upgrade. Cloud will do it for you. Right. You don't need to worry about the patch. Whenever there are loophole, people are going to do it in the cloud on your behalf. Right? That's a good idea. So increasingly, people want to use those cloud-based software, web application, to replace desktop application. Right? But you do it, you need to be very careful. The reason is to make this happen, right? And you have to break, just a whole piece of program into two parts. Some part running in your browser, while the other part running in the cloud, right? So this is very easy to understand. You cannot run the whole piece of program in your desktop, because in that case, this will not be software as a service. This will be software downloading, right? And so, but if you break the program into two parts, as you can imagine, what happened inside the program has been exposed to the network. Is that right? So imagine there's big bad guys and sitting on the network, looking at the traffic between your browser and the cloud. So that guy knows everything, what happened inside the program, right? This is not good, right? So how are we going? How can we address this problem? How can we solve this problem? Encrypt the traffic, right? Using HTTPS, right? That's a straightforward solution. We just encrypt everything, right? So you can intercept a message, but you can see nothing, right? But because everything has been encrypted. But encryption, I'm going to show you, just in these settings, encryption only can help us a little. Okay, to show you what's happened, let me give an example. So these things that I'm going to show you is, just I put a mosaic all his face, because just in the times, just when we had this discovery, we published a paper, and these things is still active. It's called Google Health. Do you guys still know about these things, Google Health? The things were shut down at the beginning of this year, but we discovered the problem about 3 years ago. The things are very active. But today, even Google Health is shut down, but there are a lot of comparable software out there. Right? Microsoft has one. There's some other party could develop this kind of stuff, right? So I'm going to show you, if you don't do it right, you will get yourself into trouble. So this is Google Health. So and the idea is you log into this, and your web account in Google Health, you can build up your own health record, right? Health profile. Let me see, and you can put your disease, medicine, therapy, whatever things into the profile and save it in the cloud, right? And of course, Google is gonna just protect your privacy. At least they're claiming that, right? And the communication between your browser and the cloud is protected by HTTPS. Everything has been protected, right? It looks like a perfect world. You don't need to worry about security, privacy issues at all. But I'm gonna show you what's happened. You go there, you log into your Google Health account, all right, your password, then you can start build up your health record. You can choose disease, what kind of disease you have. Right. Unfortunately, yeah, it's a very bad disease. And you can enter the medicine you are taking. Right. And your doctor, your specialist. Right. You can put everything there. So here's a computer, a bad guy's computer, which intercepts your communication between the browser and the cloud. Remember, you are using encryption. Everything has been encrypted, right? And that guy only supposed to see those encrypted data, scrambled data, 010101 means nothing, right? And you're not supposed to know these kind of things. It's your complete health record, your disease, medicine, therapy. And it looks like encryption and no encryption makes little difference to us. So how could this happen? Right. And this happens because we're using this software service. We break a piece of program into two parts. Some running in the cloud, while the other running in your browser. Right. The communication encrypted, but encryption cannot hide everything. Right. And it cannot hide packet size and sequence. Right, and those tiny piece of information, packet size and sequence, if you use in the right environment, it's gonna just end up betray you. It's gonna just leak out a huge amount of information. I'm gonna show you how could these things happen, right? If you go to this Google Health, you enter data, right? And what really happened is, and today they have this kind of Ajax GUI, right? And you don't need to enter the whole things to build up your health record. So what happened here is, for example, if you want to choose your disease, and the only thing you need to do is just enter a few letters, right? And for example, in this case, you enter letter A. What happened inside the system is your browser go to the cloud and grab a suggestion list that starts with A. Right. If you enter letter B, it will go to cloud and grab a suggestion list to start with AB. Believe me, in many cases, different suggestion lists have different lengths, have different size, right? You can encrypt it, but encryption, unfortunately, in this case, does not hide the length of the packet, right? So you imagine, just from attack viewpoint, attack does not know which data you entered, but it knows this piece of software, Google Health. They also can play with it, right? And so they also know the size of suggestion list you get from the cloud, right? So if you have some background in computer science, and we can easily build up a finite state machine, and with state transition, governed by the packet size, right? So using this way, we can easily figure out which letter you entered, and piece all these letters together, and we know exactly which word you entered, right? And so that's the way we can figure out, your disease. But I have to say here, just a lot of Ajax GUI stuff have the same problem. It's not only limited to suggestion blocks, just another example is here. The things, and these things here, and you have this scroll down list, right? You can enter A, it gives you a set of potential disease start with A, right? And the list that get from the cloud also different each time. And each time you choose a disease symptoms, it also generates traffic with distinctive features, which allow attacker to take advantage of it to figure out the things you enter to the cloud.